Hey there, Sevens. So I have 3 lessons left for you for the rest of the year. But because it's only 3 lessons, um, we have, I don't know, they're kind of, there's a large discussion that goes on with some of them. And this is one of the big ones. So I want to go through and look at this large discussion. One of the main things you'll be looking at today is comparing 2 different populations. So if you go down, you'll see we have like boys and girls, and we're asking questions about differences between the populations. This is usually when statistics is interesting because we can ask questions like, do boys and girls differ on quantitative reasoning? Like, are boys or girls better at math? And that was a massive question for a long time. We believed actually, and statistically, it looked supportable that boys were better at math. Now today, we found that that's false as long as we remove certain constraints. So the big one is time. As long as tests are untimed, boys and girls do have the same qualitative or quantitative reasoning. And we can ask other interesting questions comparing different sets of data, like which 2 medications is more effective in treating migraine headaches. Like that would be massively important if we were interested in selling those medications, or if we were interested in consuming one of those medications. Um, Okay, so here's what I want to look at. We're comparing 2 different data sets. Tamika is looking at whether boys or girls are faster at solving Ken-Ken type puzzles. I don't know if you've seen them before, so I was just going to show you. Ken-Ken puzzles are like Sudoku, but you have, in this case, I have the numbers 1, 2, 3, 4, 5, and I have certain things they have to make. Like these ones have to subtract to make 1. These 3 have to multiply to make 12. These have to divide to make 2. So these have to be 2 and 4. Things like that. So that's a Ken-Ken puzzle. And she looked at how long it took people to solve them. And she got that data.
Tavs jaunais modes interneta veikals ir klāt. About You. Izvēlies no vairāk.
Sorry. So good. We have Ken-Ken puzzles. She has data on how long it took them to solve them. Now, I want to take a step back really quickly because we haven't talked about this MAD, or mean absolute deviation. So let's take that step back and look. Some statistics notation that I wanted to point out to you guys. Data points are X values. So individual data points have subscripts. So X1, X2, X3, X4, those are subscripts. We've seen them come up, I think, in one other place in math, and they come up here and there. Or in general, we use X sub I is the common thing. Just to say X sub I is one individual data value, but it could be any of the data values in the set. The mean of the data set we call X bar, and it looks like that. So that's the mean, or the average. The number of data points is N. We've seen that several times already. And the summation symbol that looks like this has come up several times already. So it adds things. So the sum from X is 1 to 4. We would just add those numbers from 1 to 4 and we'd get 10. Fine, good. So these would be things I think you guys already know, except for this notation like the subscripts, and the X bar is new, but nothing difficult. So let's apply it to this data set. We've seen this data set already. For boys, I'd note that X1 is 39, just saying that's our first data point. And X2 is 38, X3 is 27, that's all I'm saying here. Just noting that subscript notation and the way it works. Obviously, if we change the order of this data, it would change which elements are which, but it wouldn't actually change the data set at all. It would just move around what subscripts are where. Which means for the boys, the sum of all of the X values would be, I'll take all of these X values and add all of those X values up, and I get 353. Great. The N is 10 because there are 10 data points. You can count them up, and there are 11 for girls. So for boys, the mean is the sum of all the X's divided by the number of data points, and this is the way we formally write the mean. So X bar is equal to this formula. And in this case, it turns out to be 353 divided by 10, which is 35.3, is fine. That's a mean. And when I look at this, it makes sense. It's kind of in the middle of the data. So this is notation things are kind of new, but just review of things you guys already know. Measures of spread. We've only had one so far. It's been range. We know it's the highest value minus the lowest value. It shows the space the data set contains. If I look back here, I could find the range. I would just be looking for the highest and lowest data points. Is the lowest 27, the highest is 43. So 43 minus 27, in this case, our range would be 16. 47, or 43 minus 27. So good, that's the space the data set contains. The mean absolute deviation, though, is different. It is the average distance of the data from the mean. So we have to find all those distances to average them. So in order to do it, in order to calculate the mean absolute deviation, we have to calculate the mean. So that's just an average, great. Calculate the distance between each data point and the mean, okay, and then calculate the average of those distances. It looks like this in a formula. Here's what this is saying. X bar is our mean, and we're going to take every individual data point and find that distance. The reason for absolute value is we want them to always be positive, and you'll see I do that by just flipping the numbers around, but we can just always make solutions positive, and that's fine. So this is one data point minus the mean, second data point minus the mean, third data point minus the mean, fourth data point minus the mean. We do all of those. We add up all of those results, and you divide by n. So this is just saying the mean is here. The distance between the points in the mean, well, that's here. That's the distance between them. And we want to average those distances, so we're going to add them all up and divide by n. Let's look at it. Given this data set. First, we calculated the mean already. That's fine. We did that right back here. We found that mean of 35.3, so we brought that forward. So we have that 35.3 is the mean. And you can see I'm finding the distance from the mean in every case down here. 35.3 comes up over and over. Then I want to find the distances between each point and the mean. So I'm going 39 is our first data point here. Minus the mean is 3.7. 38 minus the mean is 2.7. 38 was the second data point. Third data point is 27. So I did the mean minus 27 and got 8.3. But you could have done 27 minus 35.3 and you get negative 8.3 and then just make it positive or take that absolute value. And then 36 is our next data point, minus 35.3, and so on. So these are all of the distances I get when I subtract all of those. If I average those distances, so I add them all up, I divide by 10, I get this mean absolute deviation. So that was the main thing I wanted to lead to, is we have now two measures of spread. One of them is range. It just shows the space between the highest and lowest data points. And the other is the mean absolute deviation. This says, on average, the points they trend towards 35.3, but on average, they are 4 off. Like the average point in this data set isn't just 35.3, it's between whatever, 31 and 39, because we've moved 4 and 400ths up and down from there. Good. Let's look at what you'll have to do. So they actually already gave you the mean absolute deviation. Just know this is the distance from the mean, the average distance away from the average for each of these. So you'll have to draw some dot plots, and you'll have to answer some questions dealing with what does this mean absolute deviation mean? What does it do? There will be other measures of spread, so you know, but this one is kind of an important one for your understanding. It's not an important one to remember forever. It's an important one to think about. What does it mean when we average the distances? What do we get there? So I should leave you guys with this. You'll be answering based on the first data set there, and then based on this situation, you'll have to come up with a second data set. This says to work in pairs, so ideally you'll work with another person, but you can kind of make yourself be person 1 and person 2. It's not as interesting, I guess. So it'd be more interesting if you... Oh, no, you can't. I'm just going to cut off this second page. So it'll be just these first 2 pages, 7. Sorry about that. I didn't realize you couldn't do the second part without a second person. So just the first 2 pages, and that's it. Have a great day, 7s. Best of luck.